Please start attempting. What they have given, that a 200 volt DC shunt motor has an armature resistance of 0.1 ohm and negligible armature inductance. It was taking 15 ampere armature current and running at 900 rpm when field flux is suddenly reduced by 15%. The load torque is constant at 15 Newton meter. Estimate the maximum armature current immediately after flux change. So, what they have given in the question, that supply voltage is 200 volt, then armature resistance is 0.1 ohm. This is the shunt field. Now they have given that resistance is 0.1 ohm, armature inductance is negligible. That means we have to not consider the effect of inductance. It was taking 15 ampere armature current and running at 900 rpm when field flux is suddenly reduced by 15%. So, load torque is constant at 15 Newton meter. Okay. Current there it is drawing 15 ampere. Can you tell me what is the EB? Please respond. What is EB?
200 minus 15 into 0.1.
200 minus 15 into 0.1.
Not 50, sir. Field resistance is
Field resistance is given. It is given 15 armature resistance. That means this is 15 ampere. Sorry, 15 is the armature current, not the supply current. Okay.
okay.
So EB is 200 minus 15, that is 198.5 volt. So, flux can be immediately changed. EB is and running at the rate 900 rpm. Okay. Now, field flux is suddenly reduced by 15%. Why? Flux is a electrical quantity. Electrical quantity, it can change immediately. It has a very small time constant. But speed is something like it will have a higher time constant. Immediately it will not change. As soon as you will change, since there is some inertia of the rotor, it will not immediately change its speed when you are changing the flux. So, can we write EB 1 is K phi 1 N1. Okay. Then I can turn it into proportionality by writing EB1 by EB2 is equals to K phi 2 N2. Okay. Since immediately when we are changing the flux, speed won't change. So N1 only. But flux will immediately change. So phi 2 is equals to 0.8551 because we are reducing by 15%. So in that case, EB1 was 198.5 upon EB2 is K phi 1, N1 is 900 rpm upon K phi 2, that can I write it 0.85 phi 1, and speed is still the same. So what do we get EB2? The back EMF immediately after flux change will be 198.5 into 0.85. What is the value? Are we getting 168 point something? Right or not?
Yes, sir, correct.
Okay. Now they have asked estimate the maximum armature current immediately after flux change. So you are knowing field is 200, sorry, supply voltage is 200, back EMF, just now you have found out what is the back EMF, huh? Back EMF is, so supply current at this time IA2 is 100, sorry, 200 minus back EMF 168.725 upon RA. RA, that is what? Please calculate and tell me. Getting or not?
Yes, sir.
Others, if any?
Yes, sir.
Okay. So should we move to the next question? What they have asked next is estimate the electromagnetic torque generated at the instant of maximum current. Are you able to see the question?
Yes, sir.
Hmm. Hmm. So please calculate what will be the torque. Initially torque is proportional to phi Ia. Initial torque is 15. They have given in the question that torque is 15 Newton meter, load torque. So initial torque is 15 by T at this T2, let me call it, that is phi 1 Ia1 upon phi 2 Ia2. So 15 upon T2 is equals to phi 1, let it be phi 1. Ia1 was 15 ampere. Phi 2 is 0.8551 and Ia2 you have calculated as 312.75. So what is value of T2? Tell me.
So 265.8.
265.8 Newton meter. Clear? Clear or not?
Yes, sir.
Okay. Now, oof, oof. Estimate the ultimate armature current after the transient is over. This is the transient condition. because speed will not change immediately, but after some time speed will have to change. So under that condition, what will you do? Calculate ultimate armature current after transient is over. So since they have given load torque is constant, load torque is constant, that means T is proportional to phi Ia. If torque is constant, if this value is constant, so that means phi 1 Ia1 must be equal to phi 2 Ia2. Yes or no? Yes or no?
Yes, sir.
Okay. Then phi 1
Yes,
is
sir.
phi 1, let it be phi 1. Ia1 is known to you, that is 15. Phi 2 is 0.85 times of phi 1 into Ia2. This is you have to find out. Please find out what is the value. Ia2.
17.647.
Fine. Okay. Now next part is find the ultimate speed after transient is over. Ultimate speed after the transient is over. Ia2 is known to you, so you can find out the back EMF. What will be the back EMF? That will be 200, that is Vs supply voltage minus 0.1 into 17.64. What is EB now? And when the transients are over, what is the value of EB?
198.23.
198.23 volts. Okay. So again, EB is proportional to phi n. So EB initially, what was EB initially when speed was 900 rpm? That was 198.5. That is 198.5. Now we have 198.5 upon EB, which we have to EB, this EB is 198.23 is equals to phi 1 n1 upon phi 2 n2. Okay. So phi 1 is known to you, n1 is 900 rpm, phi 2 is 0.85, phi 1 and n2 is not known to you. So find out n2 by linking these two.
So 1057.38.
That is 1038.
57.38.
pm. Okay, any doubt? Any doubt in this part? Should we move to the next question? Now what they are saying, are you able to see this question? Right. After transient is over, the field flux is suddenly brought back to its initial value. Estimate the magnitude of armature current immediately at this moment. Again the same story. Flux can be changed immediately, but the speed won't change. Speed is known to you, that is 1057.38. So now they have asked estimate the magnitude of armature current immediately at this moment. Again the same story. EB was EB you found out as 198.23 something 23 volt, and it was running at a speed of 1057.38. So flux which was 0.8551, that is getting back to at 0.8551. Okay, now again one EB1 is equals to proportional EB1 by EB2 is equal to phi 1 N1 by phi 2 N2. Phi 1 in this case is 0.8551 and final phi is the original value phi 1. N1 in this case is 1057.38. Since it is a mechanical quantity, it will not change immediately. 1057.38 5 cut EB you are knowing 198.23 upon EB2 is 0.85. That means EB2 is 198.23 divided by 0.85. What is the value?
233.21.
Huh?
233.21.
233 point.
21.
Okay. Supply is 200. 200. So that will be, you can see back EMF is greater here. Yes or no?
Yes, sir.
Back EMF is greater. That means system will feed the energy back to the supply. This is something called braking. So what will be the current immediately? Transient current, that will be 233.21 minus 200 by the armature resistance, that is 0.1. That will be 332.1 something amperes. Yes or no?
Yes, sir.
Sir,
Okay.
it will be reverse.
Yes. See, immediately transient, when you will see the current, let's say current was flowing this way, 17 point something, uh, 17.64. Let's say this was armature current IA, 17.64. At the moment when flux changed, immediately it will peak back to like this and again settle back to some new value. Okay, original value was 15 ampere na? So when you have changed the flux, it will show some negative like this, go and touch the maximum value of minus 332.1 and come back, settle down as per the time constant and come back to 15 ampere, because we are restoring the original value of flux. Okay. Clear? Yes or no?
Yes, sir.
Okay. Let me move to the next question now. Any doubt in the above solved questions? Hmm. Fine. To read the question. A 230 volt DC shunt motor takes 30 ampere armature current, runs at 600 rpm against constant load torque. Estimate the minimum resistance to be inserted in the shunt field circuit to raise the speed to 700 rpm. Given armature resistance is 0.5, field resistance is 230. Assume linear magnetization curve. What do you understand by linear magnetization curve? That means if this is the flux and this is the field current, if I am increasing the field current, flux is increasing linearly. That means as per the slope. So can I write that phi is equals to KIF? Yes or no? Any doubt in this? This is meaning of this linear. Assume a linear magnetization curve. Okay, but in practical we do not have this system. If you provide at a certain time at high value of field current, the core will saturate. So what they have asked in the question, they have asked that armature current when it is taking 30 ampere, it runs at 600 rpm at a constant load torque. We have to find the minimum resistance to be inserted in the shunt field to raise the speed to 700 rpm, and load torque is still there fixed. So what will you do? First best way is to make the circuit. How? This is 0.5 ohm, this is armature, this is the supply voltage, this is 230 volt. It has given takes 30 ampere armature current, so make it 30 ampere, runs at 600 rpm. This is 230 ohm. Hmm? That means 230 by 230, that is 1 ampere it is drawing. Okay. So can I write what will be the value of EB? EB at the rate 600 rpm.
215.
230 minus 0.5 into 30, that is 215 volts. So can I write like this, that EB is proportional to, let me write it, EB is equals to K phi N. This is universal. So with respect to DC motors, now flux is getting changed. Some resistances they are adding. in the next case, in order to change the speed with a constant load torque. So load torque is constant. What does that mean? T is proportional is equals to K phi omega. Yes or no? Or you K phi n? Write it.
Sir, K phi I, sir.
No,
Huh?
as K
K
pi
phi
I.
I.
Oh, sorry. K phi I. So torque is constant. So means product of phi into I has to be constant. That means phi 1 I1 is equals to phi 2 I2. Okay. Let us see how we can do. This is 215 volt. Okay. Now this is phi. Let me assume this is. Can I write K into 1 ampere? Can I write this or not? And K into K dash, let me, this is K dash. K dash 1, K IF can I write or not? First listen this. EB. Okay. And combining this all, I will call EB is equals to K1 IF N. Clear till here? Yes or no?
Yes, sir.
Okay. Then EB is known to you, that is 215. K1 into IF is 1 ampere into N is 600 rpm. Okay. Then EB is not known in the next case. K1 into IF. Let me call this as, can I write here, let it be IF into 700. Okay. What is value? Find out the relation between EB and IF. What is, solve this?
250.833.
Okay. 250.83. EB is equals to 250.83 IF. Now come to this part. Again phi 1 can be written as K1 and K1 into 1, sorry, K dash into 1 ampere, that was IF. IF1 let me consider. I1 was 30 ampere. Now we have phi 2 as K dash IF2 into I2. Yes or no? K dash is gone. IF1 is 1 ampere. 30 is equals to IF2 into I2. Getting? One relation is here. Again, EB can be written as, EB can be written as 230 minus 0.1 into IA. Yes or no?
0.5.
Okay. What did they ask in the question? I forgot. Estimate minimum resistance to be inserted in the shunt field to raise the speed to 700 rpm. Okay, that means we need to find out IF. So EB I will write as 250.83 IF is equals to 230 in minus 0.5. IA can be written as from here, huh? 30 by, can I write 30 by IF2? We get a quadratic, that is 15, sorry, 250, 250.83 IF2 square plus 15 IF2 minus 230 is equals to 0. Yes or no? So solve this quadratic and tell me the value of IF. You can directly use your calculator and go in equation mode, and from there you can feed the values.
0.928 amps.
0.928 amps. Let me verify. Right. IF is equals to 0.928. Okay. So can I write this as V upon R external plus RF is equals to 0.928. So R external plus RF will become 230 divided by 0.928. What is the value?
247.8.
That is 247.84. Okay, ohms. So initial value of RF is already given. So R external, which is to be added in the circuit to reduce the speed, will become 230, sorry, 247.84 minus 230, that is 17.84. Mm, fine. Or did we make some mistake? Please check out, because I'm not getting the answer within the range.
Sir, I have done the same analysis, but I have got 21.39 ohms.
21.9.
39 ohms.
No, no. Okay. We will check it out once again. Just give me some time. I'll look out once. Solve again. 215. What value of IF we are getting? 0.928. 250.83 into 15, 230, something.
Sir, it's 230 IF, sir.
Huh?
Minus 230 into IF, sir.
Oh, that is the point. This is constant and this is I 230 I2. Okay. What I also thought that we have gone step by step this right way. So this will become uh, minus 230 if2 minus this plus 15 is equals to 0. Find out what is value of if. Now go back in the equation mode. 250.83 b minus 230 c 15. That is if we are getting as 0.846 comma another root is 0.070. This is not possible. 0.864, keep it here. 0.846, sorry, 0.846. So divide 230 by 8646. We are getting 271.86, 271.86, 41. What is the answer coming for you?
Same.
Same. Final answer is 41.86 ohm resistance should be added in order to get added to get speed at 700 rpm at constant torque. Any doubt? Got or not? Hello?
Yes, sir.
Any doubt?
Sir, please summarize once again.
Okay, what did we do? Okay, what they have given, they told that the assume a linear magnetization curve. That means when you are changing if, phi is changing with a linear, means there is y is equals to mx curve. Okay, that means y and x are related linearly through some constant of proportionality that is fixed. From there, what did we do? First, at 230 volt they have given, and they gave that armature current drawn is at 600 rpm is 30 amp. So first we did we calculated eb at 600 rpm, we got 215 volt. From there we know eb is related to k phi n, eb is related to k phi n. Now I have replaced phi by some constant k dash if. Huh? So because this is linear, so I wrote here k is equals to k dash if into n. Finally, this is also a constant, this another constant, I multiplied them together and gave them as kn. So I have written eb is equals to k1 if into speed. Okay. Now they have already mentioned that they want speed at 700 rpm without change in load torque. So now what I did, 215 was at 600. We do not know if value uh, because when we will insert resistance here, when resistance will be inserted here, 1 ampere initially it was drawing. So they will have some uh, actually how do they have the circuit, I'll tell you. This is the shunt field. Okay, they will okay, this will be the circuit when there will be some variable resistance. huh? Initial position was this way the arrow was there without any external resistance. This is some R external. Okay, so what I was saying. So initial current, we know that it was 1 ampere. It was 1 ampere because 230 divided by, they have given in the question that this is 230 ohm. So 230 divided by 230, this is connected in parallel. So we have IF as 1 ampere initially. Now we don't know when external resistance will be added, what will be. So I suppose that value is to be IF2. Now following the constant of proportionality relation, 215 is equal to K1 I into 600. EB is now, after change in the, after insertion of resistance, there will be some change in back EMF, that will be, let it be EB. EB is equals to IF2 into 700, like that. From there I solved this and I found the relation between back EMF and field current. Okay, clear till here? Clear or not?
Yes, sir.
Okay. Now after this, they, another point they have given that torque is constant. That means phi 1 I1 is equals to phi 2 I2. I should write IA. Huh? Phi 1 I1 is equal to phi 2 I2. So again, in that case, phi can be replaced by K dash IF. Huh? From here, can I replace phi by K dash IF? From there, initial current IA was 30 ampere. IA they had given 30 ampere. I2 we still don't know what will be the armature current. So from here, IF1 you know 1 ampere by 230 divided by 230. So I, IF2, I found the relation between IF2 and I2. That is equals to 30. Okay, I found the relation. Now EB will be, EB will be EB will be 230 minus 0.5 into IA2. Okay. Now replace this IA2 by 30 divided by IF1. IF2, sorry. I did the same. Now we get a quadratic. From there we have two roots, that is 0.846 and this is 0.070. This is very small. This cannot be possible to establish the sufficient flux. So this is, we consider this as the value, and from there this is value of IF, this is value of IF. So IF will be, this IF will be R external plus 230, sorry, 230 divided by R external plus RF. V, that is V upon R external, that which should be equal to IF. IF you have got. From there R external value you can find out by subtracting the total resistance which you will get. Fine, समझ में आया?
Yes, sir.
Okay. Now we have another question. See, similar questions are there. This is based on speed control. What is the question? A 240 volt DC shunt motor taking 16 ampere current from the supply and driving constant load torque at 300 rpm constant load torque at 300 rpm. The armature resistance is 0.5 ohm and field resistance is 240 ohm. An additional 240 ohm resistance is inserted in the field circuit. Estimate the new value of current in the motor. New value that motor will take from the supply. So first draw the diagram. Armature resistance they have given as 0.5. Field resistance they have given 240. They are saying that they are adding some external resistance, that is 240. Initially the arrow was like this, later position later this will be connected like this. From here to here they will switch. Okay. What is value of supply voltage? That is 240 volt. Motor is taking 16 ampere from the supply. This is 16 ampere. 240 by 240 initial IF will be 1 ampere. That means armature current is KCL at this point, armature current will be 15 ampere. What is value of back EMF? 240 minus 0.5 into 15 ampere. Yes or no? Yes or no? Hello?
Yes, sir. Yes, sir.
Please respond so that I may get to know that you are following. What is the value of back EMF? That will be 232.5.
5.
Okay. Now it is running at 300 rpm.
300 RPM.
Okay. Now when you will add another 240 ohm, then IF will become 0.5 ampere. Yes or no?
Yes, sir.
Okay. Can I write like this? EB1 is by EB2 is phi 1 and 1 by phi 2 and 2. EB1 is 232.5, EB2 is unknown, is equals to phi 1. When field current will become half, then flux will also become half. Yes or no?
Yes, sir.
So this is phi 1 upon 0.5 phi 1 is equals to, sorry, into n1 is 300, n2 is unknown. Okay. Again same story, some relation we will get between EB2 So what is EB2 in terms of speed? 232.5 into 0.5 upon 300 into N2. Yes or no? And they are saying that it is driving a constant load torque. That means, what does that mean? Phi 1 Ia1 is equals to phi 2 Ia2, constant load torque. Phi 1 was initially 5, then it became half. Ia1 was at that time 15, so phi 2 is 0.55. Ia2 will you will get from here. What do you get Ia2? What do you get Ia2? Ia2 is
30.
30 ampere. Okay. So what they have asked, estimate new value of current in ampere that the motor will take from the supply. So what is IF? Supply current IS will be equal to Ia2 plus IF2, that is 30 plus 0.5, that will be 30.5. Yes or no?
Yes, sir.
Okay. Now they have asked estimate the new speed. I have already found out here the relation. Huh? Now next part is estimate the new speed. Okay. Ia2 you are knowing as 30 ampere, so EB will be back EMF EB2, that will become as 200. What is the supply of 240 minus 0.5 is RA into Ia2, that is 240 minus 0.5 into 30, that is 225. Yes or no? Volts.
Yes, sir.
Now from here we will substitute here this value. So relation is ready with us. EB2 is 232.5 into 0.5 N2 upon 300. So substitute EB2 here. What will get? N2 is 225 into 300 divided by 232.5 into 0.5. Please find out the value. 225.
580.6.
What is the what? Repeat.
580.64.
580. Okay. Let me check if I am getting the same. Right. 580.64. Right. Okay. RPM. Yes. So we'll move to the next question. Hmm. Please follow. This is a good question. Can you see the question? Hmm?
Yes, sir.
Okay. A 250-volt DC shunt motor is used to drive a load which has a constant torque. At no load, the motor takes 2 ampere current, 2 ampere armature current, and runs at 1200 rpm. Armature resistance is 0.5. Normally, when load is applied, the motor takes 15 ampere armature current. Now suppose a 3.5 ohm resistance is inserted in series with the armature. Assume the huh, no load torque to be constant. This is very important. Remember, I will relate this. Assume the no load torque to be constant. That means at no load, no load power loss, or you may say no load power loss is constant. Do you agree with me or not on this statement? If I say that assume the no load torque to be constant, can I say that no load power loss is constant? Hmm? Okay. Now,
Sorry, what?
yes,
Sir, no load power loss is constant if no load torque is constant.
yes. Assume they have given that no load torque is constant.
Okay, and
Torque is,
okay.
listen, see what will happen. Torque is function of P by omega.
Sir, the no load current of the armature will be constant, sir.
Yes,
The no load armature current will be constant, no, sir.
yes. Yes. Then we will see, you will see just now when we will start to solve. Estimate the no load speed in RPM after connecting 3 ohm resistance. Okay, there are two parts in this question. First, at no load motor takes 2 ampere. Try, listen how I'll do this. A 250-volt DC shunt motor is used to drive a load. No, actually you said na that armature current, but armature torque is proportional to phi into Ia. Okay, yes,
Okay.
and phi is constant, so Ia will be also constant in this case, load torque. Yes or no?
Yes, sir.
Okay, let me sorry for that. Since we are adding resistance in armature circuit, so we are not changing anything with the flux, so flux is constant, load torque is, no load torque will be constant. That means Ia will be, Ia no load will be constant. No load case, what they are saying, 2 ampere armature current runs at 1200 rpm. This is connected to 250 volt supply. Okay, at no load it takes 2 ampere and runs at 1200 rpm. Armature resistance, what is value of EB?
Sir, 249.
Yes or no? Understood? Now they are saying that armature estimate no load speed when there is 3.5 ohm resistance in series with the armature. Huh? Estimate no load speed after connecting 3.5 ohm resistance. Tell what will be the value. Now resistance is 0.5 plus 3.5. New back EMF will be plus this external resistance. What will be the value? 248. Oh, sorry.
Sir,
4.
armature current will not change
No,
after adding
this
resistance.
it is written assume that no load friction, no load torque to be constant. So, no load torque is proportional to phi into Ia. Yes or no?
Yes, sir.
If we are not playing with this, we are inserting the resistance. Okay, let's say we are inserting resistance this way. So we are not changing, we are not playing with the shunt field. So flux is constant. So if flux is constant, so current will be constant because load torque is constant. No, sorry, no load torque is constant. Fine. समझ में आया?
Yes, sir.
4 to the 8. This way. Now, initially, again we can write EB is proportional to phi n. So, initially EB was 249. Then, since flux is constant, I can write directly as n. So, 249 by 242 is equals to 1200 by n. What is value of n? Calculate from here. What are you getting? Value 1166.26. आ रहा है इतना? Getting or not? Hmm? Guys?
Yes, sir.
Okay. Now, this is the answer. Now, next part they are saying estimate on load speed in RPM after connecting 3 point. Now this was no load, no load speed. Now on load, on load speed they are asking. This was no load. How will you do? Now EB will be, we don't know what is value of armature current now. Initially they had given when load is applied, the motor takes 15 ampere armature current. Now with respect to this we need to think, when this was the condition, let's say it was closed like this, then armature current was 15 ampere. Okay, when machine was loaded, under loaded case. Okay, now we have added some external resistance, IA will change. What to do now?
That we can find EB.
uh, let us call this as first EB under the case of this, under loaded case, EB under loaded case without resistance. Without resistance what will be? That will be 250 minus how much current they have given? 15 ampere armature current. Okay, minus 15 into 0.5. ठीक है? Yes or no?
Yes, sir.
Okay, what is value of 250 minus 7.5? 242.5. Yes or no?
Yes, sir.
Now EB with load with resistance, what it will become? 250 minus IA into 4. Let me be very specific. This is 0.5 plus R external, that is 3.5. Okay, this was so
So
tell
now
me,
what we are calculating? Load speed.
on load speed, on load speed after connecting
Resistance.
3.5 ohm resistance. Okay, how will you do? This will become 250 minus 4 IA. Tell me, what will you do?
Set 190.
Huh? IA is not known to you, na? IA under load is not known to you. First, we need to find out of what will be value of IA. So, what they have given initially, again, that thing hidden here is used to drive a load which has a constant load torque. Under load condition, this load torque is constant. Okay. So, initial current was in first case here
15.
torque is proportional to 15 into phi is constant, Can I write? Torque is proportional to phi. Oh, sorry, proportional to phi Ia. And since phi is constant, so torque is also constant. Torque is constant. Sorry, torque is proportional to Ia. Okay. So torque is constant. So what is left? Ia has to be constant. Getting or not? If load
Yes,
torque
sir.
is constant under loaded condition, so phi is constant, load torque is constant, so that means current will not change. Can I write Ia as 15 only? 250 minus 4 into 15, that will be 15 for the 60, that is 190. So what is EB? We need to find out the speed here first. Under load, what is the speed? Under load, what is the speed? We have 249, then speed was when 242, then speed was, sorry, 249, then speed was 1200. Now speed is 242.5. 242.5 is back EMF under without resistance case, huh? 242.5. Find out flux is constant. What will be the speed? What will be the speed? N without resistance under load. Tell me.
Yes, sir. I am calculating. Sir, 1168.67.
Okay. Now EB is proportional to phi into N. Huh? Here again come back. EB here is 242.5 at this speed, or at this back EMF speed is 1168.67. 1168.67 RPM. So when it will be 190 volt, then again the same logic, this divided by 242.5 divided by 190 is equals to 1168.67 divided by N. What do you get N?
Sir, this is speed at load.
Load with resistance.
Okay, both the cases phi is always constant.
Yes, because we are not disturbing this, we are not at all disturbing this, na?
Okay.
Hmm. Okay. Now they have asked estimate the let me crop and hmm. Estimate the speed regulation in percentage of no load speed after connecting 3 ohm resistance, 3.5 ohm resistance. So, what was the no load speed with resistance connected? Sorry,
Sir, 1166.26.
this is 166.26. Now, when load is connected with added resistance, this is 915.6. So, speed regulation will become with resistance, huh? That will be n no no load with resistance minus n loaded with resistance upon n no load with resistance
Sir, and loaded with resistance.
is 915.66, huh?
No, sir, in denominator will come and loaded with resistance.
Oh, sorry, n no load with speed, not loaded, because they've given as a percentage of no load speed. As a percentage of no load speed, that means that will come in the denominator. No load will come in the denominator. So this is 1168.6, 1168, 1166.26 minus 915.66 upon 1166.26. Find out what is the percentage. 1166.26 minus 915 point divided by
21.48.
21.48%. You understand? And this is a shunt machine, you know. Shunt machine, I last time I discussed, we have
Sir,
V.
it has constant torque.
Huh?
It has constant torque.
No, not constant torque. Try to understand what I'm explaining. EB is equals to V minus IARA. Yes or no? Then
Yes, sir.
I will replace flux as constant. We write na EB is equals to K phi N. Okay. This is constant because this is a shunt machine and we are not changing the uh, field resistance.
Field current.
Oh, field current exactly. So I will write here K phi n is equals to V minus IA RA. So can I write speed n as a function of current? Supply voltage is fixed, so I will write V minus IA RA by K phi. Yes or no?
Yes, sir.
So so n n suppose, can I write this n as V by K phi? I am going with little bit mathematical. IA RA by K phi. This is fixed. K phi is fixed.
Okay.
This overall is fixed. Okay. That means when IA is 0, when IA is 0, this is IA and this is n. When IA is 0, what we have value of speed? That is
V by K phi.
V by K phi. Okay. Now, when armature resistance is small, okay, when armature resistance is small, then full load resistance, sorry, full load current is there, and this part is already constant. Armature resistance is constant. Depending upon the current drawn, there will be drop in the speed. Original is, if armature resistance is very small, then there will be no change or very minimal change from no load. This is, let me call as no load, and this is, let's say, full load. If armature resistance is negligible, if armature resistance is negligible, then speed will be almost constant. That's why we call shunt machine as constant speed machine. Okay. Now, see, if you are increasing, see, when armature resistance was, consider, no load, and no load is 11.66, and which is 1200 rpm, 1200 rpm at 2 ampere, that is no load, huh? Let's say there will be a small drop, there is small drop. This is 1200 rpm. When you are increasing the resistance, sorry, sorry, okay, I mean to say, when we will increase the resistance, this drop will go on increasing. Do you agree with me or not? When we will
Yes, sir.
increase
The
the
resistance.
RA, huh, this curve will start coming down. See, we have under no load, sorry, see, no load speed without resistance, we calculated na here, that was 1168.67 under full load condition without resistance, under full load condition it was 1168.67, this was 1200, huh? Now, when we added the resistance, external resistance of 3.5 ohms, when you added 3.5 ohms, the speed dropped to 915 point with 3.5 ohm. This is with RA, sorry, this is RA 0.5. Here RA plus R external became 4 ohm and speed dropped to 915.66. Getting or not? So more resistance you will get, add in the armature circuit, poor will be the speed regulation. More resistance in armature, poorer will be the speed regulation.
Sir, indirectly we are reducing the EV
Yes, yes, yes.
by increasing resistance,
Yes.
armature resistance.
Ah, this is the formula. Oh, sorry. This is the relation, mathematical relation, which we have found out. This is the negative slope. You are seeing that slope is negative. Can I write this as n is equals to some constant? This is constant c minus this as m. This is the slope. And this is ia. Does it not look like y is equals to mx minus c? Mx minus c has curve like this. Yes or no?
Yes, sir. Yes, sir.
Okay, fine. That's all for today.